Alright. Yeah, so today we are discussing Fireworks paper. So it's a serverless framework which uses VM level and the language runtime level snapshot to solve the cold start problem which serverless function faces. So yeah, let's get to it. So let's first look through the background of serverless computing. So basically, serverless computing is more like a pay as you go uh, uh, feature where uh, you only pay for the times the function gets executed. So it's more of a granular level pricing offer from the from all the cloud supporters, Amazon, Microsoft, Google, and all. So yeah, mostly. Uh, uh, so like that setup is that there will be like small microservice level of functions, and they will be deployed separately, and um, they will get executed maybe through some trigger mechanism like event based triggering or something like that. And yeah, that's how basically it will be function as a service offering. And this is just a general setup of the serverless function. Basically they will server OS hypervisor, and all the functions will run as a sandbox. So sandbox can be of there are different abstract interface available for sandbox also, like they can run as a containers or micro VMs, or you can also run just serverless function as just VM also, something like that. So that depends on how you want to run your serverless function and what kind of isolation you want to provide. But yeah, in general, it will be some kind of sandbox with some level of isolation. And these are some of the requirements for the serverless computing, right? So on-demand execution, whenever API gets called, you do need your function to be ready to execute that request. And generally, most of these functions are like short span, saving something to database or just passing something to the front end, for example. So yeah, these are general characteristics of serverless functions. But yeah, with all these requirements, there are a few problems also, that long startup time penalty, right? What you whenever the first API hit gets called and the function is not running, you have to create the isolation level first for the sandbox to run. So mostly it's a cold start problem. And um, also how much time the function will take to get compiled, and memory also. Cloud operators have to retain some memory for those function uh, while they are maintaining. And also security challenges. So security challenges comes because the level of isolation you have to provide, it's mostly inversely proportional to the startup time it takes. So, right, so suppose you have to boot up a VM, it will take larger number of time, more amount of time, but isolation level will be pretty high. And if you want to boot up a container, isolation level will be pretty low, because almost they are sharing the kernel and all, but boot up time will be pretty low. So depends what kind of isolation you are providing. And so it's more like inversely proportional. But yeah, still, if you generally want lower boot up time, so for that you would need to go to the spectrum where the where you get a lower boot up time, right? Because that's more of a requirement from the customer side. So yeah, so this is basically there are four fundamental ways to tackle all these problems. So basically, they use snapshot and post just in time compilation and VM level snapshot, which we will discuss now. So in more detailed manner. So yeah, so how it works is that uh, first it will installation phase, it will just create a memory snapshot with just in time compilation, and whenever it gets invoked, it will load all the snapshot on a sandbox as a new function basically. So there will be two phase in this approach, that first you have to create snapshot and you load the snapshot, so which gets done every time. So suppose right now installation and invocation phase is done, right? And after a few hours function gets drained, or it gets deleted. So re, uh, um, when you restart it, it will again do the installation and invocation. So I mean, basically every time it will get redeployed, it will be deployed from the snapshot only. So yeah, so basically there are also like subsequent challenges in both of these phases, that how to do manipulate just-in-time compilation, and when do you create a snapshot, and also in invocation phase, how do they reduce memory footprint, or suppose IP and MAC address, right? So there will be multiple instances of the snapshot which will be running, and which so basically in the snapshot, everything is remains same at VM level. So IP also remains same, the IP network interface and all. So see how do they solve that problem, because it's a VM level snapshot, so all the network interface and export interface and all remain same. So they mostly use IP table and net, but IP tables and network address translation to solve that problem. And also, um, how do they pass multiple user arguments to the memory snapshot? So for that, they use Kafka queue. So basically, uh, asynchronously adds all those into queue, and then passes to all the uh, deployed instance in a asynchronous manner. And yeah, so this is the basic architecture of Fireworks and how it interacts with Sandbox. Here there is micro VM manager. So in the paper, they used Firecracker by Amazon, and they built on top of that. So basically, they are leveraging the Sandbox um, interface, Sandbox for they are creating Sandbox using Firecracker. So it's an Amazon actually created that micro VM abstraction, and also there is a code annotator which is used to uh, annotate the code, and knows that when to create snapshot. So basically, um, in the code, when during just-in-time compilation, there is a like annotation which will trigger also the snapshot command. So yeah, this is mostly this is the example of the snapshot that it adds to the main function, main triggering function. So they will add this kind of annotation, so that the language runtime knows, or at least it will get triggered. Language runtime level snapshot will get triggered. So yeah, so when to create a snapshot, right? So basically, it will create snapshot um, using that annotation only. And yeah, this one, I would be honest, I didn't understand much, but I would try to explain as much as I can. Uh, basically, yeah, they use some yeah, I would say I don't understand how are they reducing memory footprint. So we'll discuss this later after the presentation, maybe if someone understands it. But yeah, for now, let's uh, skip this. So uh, um, duplication IP and MAC, right? So basically, they have they use IP table and network namespace is more like a standard procedure, right? So in IP tables, you can create a rule that okay, if you can create a rule which can using that you can change the packet IP address, source IP, and also from destination IP, you can forward packets uh, to the process which is assigned to. So basically, they are using IP tables and net to bifurcate packets. And here, yeah, for multi users argument, right? So for users argument, as I said, they use a here Kafka queue. So for all sandbox will have a queue of their own, and it will be delivered using async. It will be delivered asynchronously. So yeah, so these are the all the different level of so it's mostly based on three fundamental tricks: VM level, snapshot, which will give high isolation level, and post just-in-time compilation, it will give fast execution, and snapshot. Because we have snapshot, we do not have to set up and compile, set up sandbox and compile the language, interpreted language every time. So basically, it will have low latency startup, and also it will be memory efficient. So yeah, basically, also they used faster benchmark and a serverless benchmark. So here, um, they used this kind of matrix multiplication uh, uh, testing, and then factorial testing, and then disk testing, and network latency testing. So here you can see the comparison with other serverless frameworks like OpenWhisk, Gvisor, Firecracker, and Fireworks. So here you can see with OpenWhisk and Gvisor, there are two basically data points: cold start and warm start. And here for Fireworks, it's only just both, because with Fireworks you have to, it just creates a snapshot and install the function every time. So it's just the same procedure every time. So there is no difference between cold start and warm start. And as you can see, Fireworks um, does take much less time compared to all of these frameworks. So here you can see like it's pretty low. Um, and yeah, also because of the memory optimization they did, Fireworks can basically makes more consolidated sandbox than Firecracker. So because of that, cloud providers can run more amount of sandbox in a VM. So it's a cost saving also. And yeah, so overall, they had 20 times shorter cold startup time and 7 times lower memory footprint with these three techniques of VM level, snapshot, language runtime level, snapshot, and yeah. Uh, so, yep, that's it.